All right, this is AP Calculus Unit 7 Pretest Solutions. So a particle is moving along the x-axis. Velocity is given with this function. And we do have our calculator on number 1. So let's open up my calculator really quick.
Do you have an extra one, Mr. Snow?
I do. So you can come grab it. It's right on the corner here. All right, so a particle moves at time equals 0, the particle is at x equals 1. Find the acceleration at time equals 2. So let's go ahead and input this into our calculator. This is going to be negative in parentheses, and then I'm going to do t plus 1. And that's going to be times sine of, and then I don't need to do parentheses because order of operations will hold true here, divided by 2. All right, so I have everything in here. I'm double checking to make sure I got everything correct. Good. Okay, my interval looks like it's going to be between 0 and 3, so I can set that now. 0 to 3. I am in radians. Good. Okay, and then I hit zoom 0. Okay, I need to find the acceleration at time equals 2. I actually don't need a graph for part A. I guess I'm just getting that out of the way right now. To find acceleration for part A, acceleration of time is equal to velocity prime, the derivative of velocity. So when I do velocity, when I'm plugging in 2, the way that I do that on my calculator, let's get out of this second quit, is I go to math and I'm going forward, so 8. I'm taking the derivative of my y1 function, vars right, enter, enter. y1 with respect to x at position 2, so enter 2. And we get 1.588. So that's going to be our velocity 2, 1.588. All right, and that is, I do need to explicitly say that's acceleration at time 2. Yeah.
I think I got that mixed up because I just put the interval, like instead of just putting it at position 2, I put between 0 and 3. So that wouldn't be, that you wouldn't get the right answer then, would you?
Right, yeah, you probably put 0 and 3 here. In your calculator, yeah, you have to put 2 when you're taking derivative. Derivative only takes 3 inputs. When you put that 4th input, it doesn't know what to do with it, and it kind of just excludes it, I believe. Maybe that's wrong. So that's the first part of the question. What is the acceleration? The acceleration is 1.588. By the way, in AP Calculus, when you are writing out a number, you always round to 3 decimal places, and you either truncate, which means you cut off and don't round, or round. They count for both. Truncate is the technical word when you just ignore the rest of the number. If you round to 2 decimal places, you won't get the points. And if you round to 3 decimal places incorrectly, you'll also miss a point. So is the speed increasing at time equals 2? So we have acceleration at time equals 2, but we need velocity at time equals 2. The way that we do that is easy. We go to our graph that we graphed and we punch in, we have to go to trace, and then we punch in 2, enter. And at x equals 2, y is equal to negative 2.72. So this is negative 2.728 if I'm rounding correctly. And I notice that I have a positive acceleration, negative velocity, therefore the speed is decreasing. So from here, speed decreasing. And you not only have to say that, but you have to say also because different signs. V and A, different signs.
Will they take points off if you don't round exactly right?
Yes, they will.
How about if you got,
I did it to Carly's test too.
You did it to my test.
Also?
How about
I'm not really
if you
sure.
got,
Or maybe it was only Sophia's.
if you got decreasing but you got the numbers wrong but you got like the signs right?
So yeah, you're asking about the scoring?
Yeah.
So 1 point if you got 1.588. And actually, Isabel, you can score yours right now for me because I'm going to teach you guys how to grade it, and that will be perfect. You can just add
Can I
them all up.
show you some pen?
You want to use a red pen? Rosalie, I can give you a red pen as well.
Yes.
This one? I couldn't see it.
Yeah, it's dark in here. All right, so they have red pens. We're ready to go. Okay, and how do I get my last point? So you have to have speed decreasing, and you have to have your explanation. So give yourself another +1 if you have decreasing and you have your explanation because vertical or velocity and acceleration have different signs.
I didn't put velocity.
All right, questions about part A. Moving on to part B then. So part B, this is asking us to find all times when the particle changes direction. So changes direction means velocity is equal to 0, and we notice that we have this x-intercept, or the t-intercept, I guess, for this problem, we need to find that position. So we do that by doing second trace, and we go to our 0 by hitting 2. And I'm just going to go quick here. I'm going to hit 1, enter, 3, enter, 2.5, enter for my guess. It's really rough, and I get 2.5066. So, and that is the time. So t equals 2.506. I guess
Wait, zero.
you can do 0.06 or 0.7. Both of those will be plus 1 point.
Oh, either one is okay.
So either one is okay.
Choose to round or not.
You can choose to round or not. Exactly. Truncate is not rounded.
So either truncate or round.
Exactly.
I choose the truncate.
I prefer rounding because that's more universal. When you go to college, most people are going to say you need a round.
Okay, I prefer
So that will give you 1 point, but you need your second point to justify your answer right here for part B. So why is this the answer? So it changes direction, and you need to have something along the lines of because v sign change. If you have velocity sign change, also give yourself another plus 1.
And that's because that's the 0, right? 2.5.
Yeah, that is the 0 on our graph.
Wait, Mr. Sindel, can you explain how you got it again?
Yeah, so on my graph, you know how to set the window, how to enter the equation, right?
Yeah.
So I go to second trace, and then I need to find 0, so I hit 2.
Okay.
And I need to say left boundary somewhere on the left. Any of these points. I can enter 1, 2, 1.5. I'm just going to enter 1. And right boundary, the farthest right that we can go on our graph is 3. That's where the window is set. And then somewhere in between 1 and 3, any number between 1 and 3 will work. If you enter 2, it'll still work. 2, and it will tell us 2.506.
Yay.
That's a quick way of doing it instead of going left and right with the arrow keys. All right, everyone good on part B?
Yeah.
All right, 2 points there. And let's go on to part C. Do I have enough room to do part C on here? I think I do. I can move the calculator and move to the right also. So for part C, find the total distance traveled. So total distance traveled is, yeah, we already know this. I think everyone got this. From 0 to 3, of the absolute value of velocity with respect to time and absolute value dt. So how do you score this part? This is out of 3. This one was out of 2. This one was out of 2. So C is 3 points. You get 1 point if you did the bounds. 0 and 3, that's 1 point. Right there. If you have an absolute value vt dt, all of this stuff, give yourself another plus 1. And then we actually have to find what that is equal to because it's asking us to find it. You don't just evaluate or write a function. So to do that on our calculator, I'm going to do it graphically, although I know you know how to do it without a graph. So the way to, actually, I'm not going to do it graphically. I think that takes too much time. I'm going to do it without a graph. So the way that I do that is I go math 9. So I'm doing the integral of, and I'm not going to just do y1. I'm going to do absolute value of y1. So I do math, right, enter. So the absolute value of vars right, enter, enter, y1, end my parenthesis here because it's doing absolute value of y1, end the parenthesis here saying I'm taking the absolute value, comma, variable, comma, 0, comma, 3.
So,
Can you leave that up there for 1 second?
I will, yeah.
Mr. Sindel, you want to know what I ended up doing?
Sure.
The answer, spoiler, is 4.3338. Me being so dumb, put 4.338. And then you're like, AP Calc is extremely precise. This can either be a 3 or a 4. And it's just because I
You missed a decimal.
yeah.
Okay. Got it. Okay.
It's okay.
Because I just keep always forgetting that it's math, right, enter to get abs, right?
Yes.
So I need
Wait,
to
how did you get 4.334?
I'm rounding this last number because the next digit is an 8.
Oh, I thought that was a 0. I was like,
too, I
Mr.
was like-
Sindel.
Yeah. So you can, and you'll get a point either way. If you do 4.333 or 4.334, that's still another point. So that's how.
Not 4.338.
Sorry, Sophia. Yeah, you will actually lose that point on the AP test too. So be careful.
It's a good learning experience.
I like how you said that. It is a great learning experience.
Amen.
All right. Let's move to part D. So I don't have enough room on here. I can do it on the next slide.
All
So,
because I didn't write it in my conclusion.
right. Yeah, that conclusion is important. So during that interval, 0 to 3, what is the greatest distance between particles? So when I'm looking for greatest distance, I need to make that table. So, and everyone did make the table that I saw. So 0 and, where did we have that 0 again? The 0 was at
Start position 1.
2.507. 2.507, because that's a critical value, right? I don't know why I did 6 there. Oops.
You missed the ball this part.
2.507. And I also need the end position, which is 3. So those are the times that I'm looking for. And I'm also going to need the formula start plus change. And that's equal to the end. And I make my table. Oh gosh.
Oh gosh.
So in order to have the calculator on here, I can't undo, which just means I have to alt-tab back and forth. So what is the start value for all of these? The start value at time equals 0 is 1. So 1 is going to be the start each time. And I need to add every time the integral between 0 and 0 for this one of velocity of time with respect to time. The integral between 0 and 2.507, 2.507 of velocity of time dt. And the integral between 0 and 3 of velocity of time dt.
Between 0 and 0, it's always just 0, right?
It's always 0, yeah. And that's a rule that is really just easy to memorize, I guess. If it's the same value, don't worry about it. So when I do that, 1 plus nothing is 1. And then now I need to do this. On my calculator, I can do this all in the same step. I can do 1 plus the integral. So I'm going to do 1 plus the integral. That's going to be math 9. The integral of my y1 value, so var is right, enter, enter. y1, and that's with respect to x. And then between 0 and 2.507, 2.507. And when I do that, I get negative 2.265. So negative 2.265. And again, I need to do the same thing for 3. And here's the trick. I don't need to do this whole thing again. I do second enter, and then I just change this end value. I hit delete a few times, and then this value is a 3, and I hit enter again. It's a quicker way of entering everything. So this is going to be a negative 1.197. And again, the greatest distance, not to the left or right, just away. So the greatest distance is this one. And notice that they're not asking for time. Sometimes they ask for what time is the greatest distance. This one is just asking for the distance. So our conclusion is negative 2.265 is the greatest distance. Is the greatest.
I was gonna try and trick me because. Wait, no, it's the next one. Just kidding. I'll explain that.
From the origin.
No, it's not the next one.
Perfect. Okay, so how to score this thing. This is out of 2 points. So out of 2 for part D. The first point is you have to have this integral. You have to consider between 0 and 2.507. You need to find this change correctly. So if you have everything right here in red correctly, give yourself +1. And if you have your conclusion, which is negative 2.265, if you have that as the greatest distance, and you say that is in fact the greatest distance, give yourself another +1.
So, if the question asks what is the time, then you write the time. If it asks for the position or the distance, then you write the distance.
Exactly. And sometimes they ask for both.
Okay, because I put both because I remember you saying if you write this, you're gonna get it wrong. It needs to be the time. But then I got very scared.
Yeah.
Okay.
And that's
It depends
I
on what
did
it asks
right,
for.
and then
Yeah.
I got it wrong.
We're talking about number 2, right? The second problem that we haven't got to yet on here.
Sort of.
Okay, so that number 1 was out of 9 points. So go ahead and score yourself out of 9. This whole thing was out of 9. Okay, let's move on to the number 2, the second problem.
Wait.
So this one is going to be a little bit weird because you guys all did it, you girls all did it with a calculator, and there shouldn't be any calculator. Ooh, can someone run and tell Joy that number 2 and 3 are not a calculator? Because I forgot to tell
Probably
her.
already on it.
She might already be on it. And if she's already on it, she's in the office. If she's already on it, tell her to keep going through it and don't do a calculator for the next one.
I don't think I could have done 2 without the calculator.
I'm going to show you how to do it with a calculator right now. So here we
You
go.
mean?
So no more calculator. Let's get rid of that.
I think you know that.
All right, so for part A, find the acceleration at time equals 1. So I have my velocity, and we know that acceleration of time is really just the derivative of velocity, v prime of t. So how do I find the derivative of this? Notice I have one term, one function, and another function, and they're being multiplied, so I am using, okay, go away. So I'm using what rule? Product rule, yeah, so that's going to be, I'll write it up here, 1d2 plus 2d1. All right, so I think everyone in here use a calculator. Shake your heads yes if you use a calculator. Okay, so that means you guys are working with me to do this problem. So product rule. Acceleration of time is going to be equal to 1d2. Tell me what to write.
I started at number 2. I'm sorry.
2 minus t
2 minus t.
e to the 1 minus t because it's e.
Yeah, be careful here. E to the 1 minus t
Time.
Oh,
The
times
negative? Wait, what?
times -1.
times -1. Yeah, be careful of that inner. Inner is negative t, dinner is -1.
So,
You want to move
oh
it
yeah.
back because I don't know.
Okay, plus.
Wait, what?
You wanted to move back the trash can.
Oh, I think we're done.
Okay, what's 2, girls?
E to the power of 1 minus t.
Okay. All that times
-1.
times -1. There it is. All right, and I need to simplify this eventually, but I think there's a trick here where I don't simplify it. I just plug in 1, but I think I might eventually need to. We'll see what happens. So let's find the acceleration when we plug in 1. When I plug in 1, this is going to be 2 minus 1, which is just 1. E to the 1 minus 1. And that's all times -1. Plus e to the 1 minus 1. All of this times -1. Okay, that simplifies a little bit. We need to simplify this in order for this problem. Actually, no, we don't. Not for part A. So that's part A. You get your point just by doing that. So there's 2 points for part A, and you can score yourself according for the calculator. Somehow you can give yourself 2 points. If you got -2 just from the calculator, you can give yourself 2 points. But the
You gave me only 1.
so you have to write this. You have to say acceleration of time is equal to the derivative of velocity. If you don't have that, you don't get a point.
Oh, you
You do need that. So if you accidentally wrote that and you gave yourself a point, that's awesome, but you always need to be writing them. You need to tell the grader, hey, this is what I'm doing. I'm finding acceleration by taking the derivative of velocity. Otherwise, you write out a bunch of stuff and you're like, wait, this is incorrectly taking the derivative, and they can't tell what you're doing. All right, so you give yourself 1 point if you wrote that, and then you give yourself another point if you have this. And this actually does simplify to -2. So if you got -2 for part A, give yourself 1 point there. So there's 2 points you get for part A. Questions on the grading?
No.
All right, on to part B. So for part B, it's asking, is the speed increasing? So that means we need to compare what and what?
Velocity and acceleration.
Yeah, at that time. So velocity, I guess I'm not writing v of t. It's velocity when I'm plugging in 1. So I need to plug in 1 into this formula, and that's going to be 2 minus 1. All that times e to the 1 minus 1. And that simplifies to 1 times, what's e to the 1 minus 1 simplified? Just this part?
E to the 0.
Which is?
1?
Yeah, 1. And then 2 minus 1 is 1. 1 times 1 is 1. Perfect. Now let's do acceleration of 1. Oh, we already know what that is. That's this thing, but we need to simplify it. The reason that we need to simplify is because we need to know if this thing is a negative or a positive. Once we know that, then we can tell if the speed is increasing or decreasing. All right, so 2 minus 1 is 1. So don't worry about it. E to the 1 minus 1 is
0, 1.
0, 1. So e to the power of 0, and then 1. And then times -1. So all that turns into a -1. So that was this whole first term. And then this thing, e to the 1 minus 1 simplifies to 1. And then I have another -1. And that simplifies to -2. All right, so from these two facts, I can try drawing that a little bit better. From these two facts, I know it's increasing or decreasing.
Decreasing.
Yeah, so speed decreasing. And then you can't just say that, you have to say because v and a, velocity and acceleration, have different signs. Different, whoa, computer's nuts. Up to date.
So, Mr. Sundell,
Yes.
for acceleration at 1, I got -1, but I still said the speed is decreasing. Is that a point?
So I think, I'm not exactly sure.
One little mistake wrong.
I
I got v1 equals 1.
I think you'll still get the point if I were a guessing man, but I'm not sure. That is a question for Mr. Wynn. I'll ask him.
I'm gonna give myself a point.
Please give yourself a point. That's what I would do too. So give yourself +1 if you said speed decreasing. If you said speed decreasing +1, and you have to have the reason, because velocity and acceleration have different signs.
See, what sucks, Mr. Sindel?
Yes.
Is that, this seems pretty easy now, but we still have like 5 more sections of multiple choice. Like, it could be any one of these example problems out of 5 huge categories.
That is so true, because like on this test, at least we know what
Yeah,
it's gonna be
we
this,
knew.
you know?
Yep, and I understand your frustration, but we'll have a lot of time to review and make sure we
Yeah,
know
that's what
everything.
I'm getting. But when we do that, are we gonna take tests where it's like any combination of like multiple choice from the beginning of the year and then like this and then like,
Yeah,
you know what I mean?
everything, yeah. We are going to be doing that. All right,
Those are just for practice or what?
just for practice, not graded. Well, I mean, I'm going to grade them, but they don't affect your grade.
Oh.
All right, so for part C, find all values of t at which the particle changes direction. Okay, so this changes direction, that means we're looking for what?
0.
Yeah, so vt, the velocity, we need to find where that's equal to 0. So how do I do that? Well, I take this vt and I set it equal to 0. I say, okay, this 2 minus t times e to the 1 minus t, that needs to equal 0. All right, and this can be tricky for those of us that have, Algebra 2 has been a while ago, yeah? So this is just product rule, zero product property. So this times this equals 0, that means this equals 0 or this equals 0, right?
Yeah.
All right, so let's identify these two things. So either 2 minus t equals 0 or, and technically this is an and, I guess, because we're checking both of these things, or e to the 1 minus t equals 0. Okay, well, let's check this one. T is equal to what here?
-2.
Careful.
Just kidding, 2.
2, yeah. All right, what about here? Can I ever get 0?
No.
Nope. And the reason for this is whenever I have an exponential function, when I have a number for a base, e is just a number, and my variable's in the exponent, this can never be equal to 0. All this will do is get to a really, really small fraction, but it can't actually get to 0.
So that's whenever the variable's in the exponent.
Whenever the variable's in the exponent, that can't be 0. It's a good way to memorize it.
I wrote there are no values of t, and I went on this huge tangent hoping I'd get some point.
I saw that, yeah. No, that's good. You have to kind of BS your way through the test just in case that's the right answer, but unfortunately it wasn't.
It gets you to make it.
Yeah.
Exactly. So let's go ahead and look at our number line, just like we did in, I don't even know, was that unit 3 when we were testing signs?
God.
So at t equals 2, we need to choose a value on the left and the right to see if it's actually changing direction. Because if it's positive and positive, then it's not changing direction. So we have to prove that it actually changes direction. Okay, let's choose a point on the left.
0.
Great point. So when I plug in 0,
9.
2 minus 0 is positive or negative?
Positive.
Positive. When I plug in 0, e to the 1 minus 0, is that positive or negative?
Positive.
It is, yeah, so that's going to be positive over here. And you guys remember the trick to see if it's negative or positive?
If it's
No, I still have to calculate it.
It's an
Oh.
If you have to recalculate it, that's fine. I'll show you the trick now. So this thing will always be positive as long as I have positive values of t. Sorry, that's not correct. Are you okay?
Yeah, she just really hit me. Oh, God.
So this base, if it's positive, this thing is always positive. So don't worry about this. The base affects the positive or negativeness of this term.
so if the base is positive, then
Wait,
it's
what does the base mean?
This number. If this was a negative e, then it would always be negative. If it's a positive
the
e,
outside of the parenthesis?
so I'm just talking about this thing right here. I still have the 2 minus t to deal with because I have two things that are being multiplied. I'm saying this thing being multiplied, it's always positive
Okay.
because it's a positive e.
Okay.
Now I have to check this thing. 2 minus t, well, that's to the power of 1. So it does switch because it's to the power of 1. It's an odd power.
non-power. That's what I was telling you.
Yeah, you have to check both of these terms. You have to know that this one is always positive too. If you don't like that shortcut, you can go ahead and resubstitute things in. So it does switch signs, and therefore we can say at t equals 2. Yep.
And do we have to say v sign change?
Yes, exactly. So this one is out of 2 points, and there's 1 point if you say t equals 2, and then the other thing that Sophia just said is you have to say because v sign change. And that'll be
Yeah,
your
I
second
got
point.
the V sign change, but I didn't do the little chart thing. I don't know how I got V sign change, but I did.
Yeah, so if you memorize the definition, that's a point. That's why it's important to memorize that definition.
Just wrote it down.
All right, and then part D, I'm going to squeeze it in here on the top right. Part D, write but do not evaluate the expression that gives total distance. And I think everyone more or less got, I think everyone got that. I hopefully am not wrong. That's between 0 and 3, the absolute value of velocity of time and absolute value dt. and how to score yourself. This one is also going to be out of 2 points. Every single problem here was out of 2 points for this number 2. So if you got these ranges between 0 and 3, give yourself +1. And the second point, if you got the rest of this correct, give yourself +1.
And it's okay that you write VT
VT, yes. It saves time.
and money, life insurance.
Wait, what else did you
You could write out this whole function.
Yeah.
do? Oh.
All right, are there questions on how to grade number 2? Questions on how to do the math on number 2 at all? All right, we're moving on to number 3. And the hardest of the problems, in my opinion. Again, number 3 was without a calculator. So how do we do part A? And you'll notice that part C and D are on the next slide. That's why they're missing. Part A. So I need to find the time and position of the particle when it's farthest to the left. That means we're making a table. So I need t values. I need a start. And I'm going to add the change.
Thank you.
And that's going to equal our end value. All right. So what values of t should we use? So, yeah, go for it. 0 and
3, 5, and 6.
0, 3, 5, and 6. Yep. So we can do those. 0, 3, 5, and 6. I think I can squeeze these in here. So there is a trick here. You don't have to do every single one of these values. Can anyone tell me why? Or tell me which value I don't need to check?
6?
You.
3.
So farthest to the left, you do need to check 6.
Wait, I thought
One of those is correct.
6 isn't actually a 0 though.
What was that?
6
an
isn't a
endpoint.
0. It's an endpoint.
It's an endpoint, yeah.
Yeah.
Because we're looking for the position farthest to the left. So obviously this is a negative value, so we do need to check 3. That could be farthest to the left. But look, at 5, I'm going backwards. I'm going back to the right. So at 5, I'm going back to... I know that 5 is not going to be the answer because otherwise 3 would have been the answer. But 6, I'm going to another negative value, so I do need to check that.
You did.
And I might have started at a negative value. So really, I only need to check 0, 3, and 6. I can skip 5, just kind of using some logic.
Sometimes I get confused with my lefts and rights, so I think it's smarter if I just keep all of them.
If you want to keep all of them, that's fine, yeah.
One.
Yeah, like
Yeah, it kind of confuses me.
So the start position is what, girls?
negative
Negative
2.
two.
Yep, -2. So start is -2 for each of these, and that goes down all the way down here. And I'm always going to add the change, as the change is going to be between 0 and 0 of our velocity function, vt dt. It's always going to be the integral between 0 and 3, 0 and 5, running out of room, and between 0 and 6. And all of these are always going to be vt dt. I wish I could, I'm going to copy and paste that in my mind. Okay, then I need to actually find what that is. So, this is going to, oh, and it tells you what our areas are. I should write these in here. So between 0 and 3 is 8, between 3 and 5 is 3, and between 5 and 6 is 2. So this is actually pretty easy math then. So it's going to be -2 for the first one. For value of 3, it's going to be -2, and then I'm going to add a -8, so that's going to be a -10. And then I'm going to go backwards to a -7, and then I'm going to go, this is going to be a -2, so I'm going to go to a -9. -7 plus -2 is -9. So I'm looking for the position farthest to the left, and we can see that, I shouldn't do this in red yet, -10 is the farthest to the left. It's the most negative out of all of them. And it's asking for not just the position, but the time and position. In the instructions, we need both this number 3 and this number -10. Yes?
How did you get -7?
So -7, I had, you know how I found -10, right? I had -2 plus -8.
Oh, I forgot the -2.
Okay.
That's why. Never mind.
Okay, good. And then, so I need to actually answer my question, and the answer is at t equals 3, position is -10. Farthest to the left. And I need to somehow say that. Farthest left is this. So I have the time, I have the position, and I'm telling you that's when it's farthest to the left. So how to score part A. Part A is out of 3 points. And you get 1 point. And the scoring here is really weird. You have 1 point if you have the value of -10. So 1 point if you have value of -10. You get 1 point if you considered this value. So if you considered this value, and you actually wrote out all 3 of those, then you give yourself another +1. And then having your perfect solution farthest left at t equals 3 in position -10, give yourself another 1 point.
What if I only put at time equals 3, do I not get a point? Because I just put that farthest to the left at t equals 3, not position.
You have to have the time and position. You can't give yourself a point if you only do the time. Although I have a feeling that if I talk to Mr. Wynn, he'll say, oh, if they have the table and they have all their values right, then you give yourself a point. But I'm going to be extra strict, error on the side of not giving you points.
Safe than sorry. If you get like that one crabby test grader, it's like, oh, they wrote it and they got it right, but I wanted a conclusion.
Right. So I'm going to say, yeah, in your conclusion, it needs to be in there. It needs to be both. All right.
I feel like that's better for me because
Yeah.
then I don't get mixed up.
And if I
Which one
keep
they're
doing
asking
something consistently, like if I do that consistently,
Yeah, I get you.
Okay, so for part B was totally extra credit. It's out of 0 points.
Will that be
using
Wait,
I
will that be
completely
on
guessed.
the test?
It will be on the test, and it will also be extra credit. Something similar to B. So, how do you know how many times the particle is at position -8? Well, you look at the position. So these are all of the critical values. So this is the general idea for how to figure out that it's -8. Kaylin had a really good explanation if you want to check hers out.
Yeah.
So between -2 and 10, I pass through -8. Between -2 and -10, I pass through 8. Between -10 and -7, I pass through -8 again. And because -7 and -9 also has -8 in that interval, I pass through it 1, 2, 3 times.
oh,
So the answer is 3 times,
that is not how I got that.
because there are 3 intervals that it has that -8 is included in. That is enough to give yourself 1 point. Technically, on the AP exam, this is out of 3 points, and you do need to hit all 3 of these to get a perfect 9 out of 9. I will tell you how to get the other points really briefly, but it's not super important. You have to say by IVT. Not only do you have to say by IVT, you have to say that because it's continuous, I can use IVT. And IVT guarantees at least 1 point in the interval. So between each of these intervals, there's at least 1 point that I hit that is -8. Do we remember IVT at all?
Yeah, IVT, EVT, MVT.
Okay, so you remember the acronyms. Do we remember what IVT says?
Guarantees one at least.
That there's a sign change.
No. So IVT essentially says if I have a continuous function, between these 2 points, then every height between here and here is hit exactly once. Not a height outside. It's not guaranteed. It might be hit, but it might not. But every height in between these 2 points is hit at least once. It could be hit multiple times, right, girls? Because I could have a function that looks like this. It could be hit multiple times. This point right here is hit 3 times, for example. IVT guarantees at least 1 point. Then you somehow have to say it's not more than once. How do you know it's not more than once? Because we know that the velocity is explicitly negative or explicitly positive in between these intervals. Between -2 and 10, between these positions, -2 and 10, that's between times 0 and 3. Look at times 0 and 3. Between times 0 and 3, the velocity is always negative. And then you have to say, there's the word here, position is monotonic, which means it doesn't change. It's always positive or it's always negative. It's strictly one or the other
But this
because velocity monotonic.
But this one will be extra credit on the AP.
This is extra credit. And that's why I'm going over this really briefly, not super in
Not on
depth.
the AP exam,
This one will be on the AP exam,
but
but
as extra credit.
no, you don't need to get the full 9 out of 9 to get a 5 on the AP test. Not only do you have to say that, but you have to have all of these points. So if you wrote your table out, you could have gotten a point here. I didn't give it because I was considered that part of A. The strict guidelines for the AP test on grading say you have to say 3 times, you have to have IVT, you have to talk about monotonic, you have to talk about, what's the last thing? 3 times in the position. So there's 3 points that you could have got. If you said 3 times, which Kaylin did, you give yourself +1. If you have this giant bunch of nonsense, that's another +1.
I did too, damn.
And if you give yourself another 1, if you include all of the position vectors for the right intervals.
completely
Just kidding,
like
Mr.
guessed
Snow.
it.
I guessed because I saw 3 dots on the line.
That's what I said. That's what I did too. And then
I
Okay.
didn't really understand the question. So I just wrote, it only crosses one time.
Yeah, but does everyone understand the question now?
Sort of, but I don't think I'd get it right. Again.
So the intervals, these intervals are the reason that there's x equals -8 at 3 points. There's one interval here, and the third interval here.
What would be an example if it didn't cross it 3 times?
So if this was a -9 right here, then it goes from -2 to -10, so it hit it in that interval. But between -10 and -9, it didn't hit it in that
Because
interval.
it didn't go low enough to negative. Oh,
Exactly.
Okay, I get it now. Thank you.
Perfect. Okay, let's move on to part C. So for part C, on that interval, is the speed increasing or decreasing? So this is weird because normally they say at this specific time, but now they're saying an interval of times, is it increasing or decreasing? So we have to check basically every single point between 2 and 3. So we come back here to 2 and 3, between 2 and 3, and we notice that in this interval that they're talking about, we need to compare what 2 values again? I'm right.
Yeah.
Velocity and acceleration.
Okay.
All right, so the velocity between 2 and 3 is always velocity here. The height is always positive or negative? Yeah, so the velocity here is always negative. So you can write this is equal to always a negative. What about the acceleration? What about the slope?
it's always positive.
Always positive. So this one is always positive. That's all you really need.
What is VT again? Sorry.
Velocity. Velocity with respect to time.
But is that slope?
So if they give you a graph of v, that's going to be height.
So VT is height.
Mr.
Yes.
Sindel, what if it asks, like, what if the graph is really weird between those points? Like, can I show you an example?
Yes.
Like, what if it's between 2 and 3, for example? That's 2 and 3. And it goes like that, in between 2 and 3.
So then you can say that it changes a bunch of times. So let me draw on the notes what Sophia's drawing so we have it for the records. So Sophia's saying if this is 2 and this is 3, what if it does something like this? And the answer is they won't ever give that to you on an AP test. It'll be a simple 1 change or 2 change. So don't worry about it, is my answer. All right. So part C, we need to say that speed is therefore what? What is going on? Speed decreasing. And what's our rationale? What's our reason?
V and A have different signs.
Yep, because velocity and acceleration have different signs. Okay, and then how to score yourself for part C. This is out of 2 points. So you give yourself 1 point if you have the explanation, and you give yourself 1 point if you say that the speed is decreasing. All right, and then on to part D. We're doing good on time. So part D is asking, during what time intervals, if any, is the acceleration of the particle negative? All right, acceleration, what is that? In terms of the graph. Yeah, so we're looking for slope. Slope negative is essentially where it's what it's asking. So where's the slope negative? Between 0 and 1, the slope is negative. Anywhere else? Yep. Between where and where?
4 and 5. 4 and 6.
4 and 6, yeah. So between 4 and 6, all of these slopes are also negative. So 0 and 1, 4 and 6. So between 0 and 1 and 4 and 6. So you can write it like that. You can write it 0 is less than t is less than 1, and 4 is less than t is less than 6. Somewhere in these intervals, you need to have those intervals, and you also need to have your rationale, because it says justify your answers. So we'll say because, what's our rationale?
Because the slope is decreasing in those intervals.
Yeah, so the definition, you can say slope, but you need to really say what that slope represents. What is that slope?
AT.
It's AT, and that's found by taking v prime of t. So they gave us a graph of v, so somehow we need to have v in our answer. So it's v prime of t is less than 0. Is less than 0 on those intervals. This is just a definition that you need to know. This is slope when I'm given, or it's the definition of acceleration when I'm given velocity. You need to know that that's v prime of t. So that's +1 if you have v prime of t is less than 0 or something along that line. And you give yourself another +1 if you have these two intervals correct. So that's also out of 2 points.
So if you did say AT is less than 0, it'd still be a point? Or would you want us to write v prime of t?
It needs to be v prime of t.
Let me write that.
Because they didn't give us a graph of acceleration. If they gave us a graph of acceleration, then I would accept that, but they give us a graph of velocity.
Okay.
And since this problem is basically regurgitated with different graphs, you only really need to memorize this definition. V prime of t is less than 0. That's acceleration less than 0. Or acceleration with negative slope. Or negative acceleration. Can't talk.
What are you saying?
I don't know. All right. So A was 3 points, C was 2 points, D was 2 points, and the bonus question B is out of 0. So that means this entire problem is out of 7. Out of 7. Score yourself if you didn't already.
Just to know you added it wrong.
3 plus 2 plus 2, isn't that 7?
Mine. I got 3, 4, 5.
Oh.
You did 4 out of 7.
I apologize. I'll change that. Can you change it right now for me, and I'll change that in my gradebook? Good catch. All right, so we have 7 more minutes left of class, so let's go through these multiple choice questions. So number 4, this is going to be top-bottom rules. I don't know why I'm choosing red. So top, bottom. So we're looking for the highest degree terms. That's this n cubed and this n cubed. Forget about everything else. And then I make that into a fraction. And as it goes to infinity,
3.
it's going to be 3. Questions? All right. Every single multiple choice question is worth 1 point.
Wait, I have a question.
Out of 1 point. Yes.
If it's 0 again, then we do
There's 3 steps.
Factor.
Factor.
Oh, yeah.
cancel, plug in.
Exactly.
Okay.
Good memory.
I remember when we did that.
All right, number 5. The slope of the line tangent to this graph at x equals 4 is, okay, so
I was so good.
line tangent means we're taking what?
The derivative.
Taking derivative. So we need to find y prime.
Oh, I was trying to do the like whole box.
Wait,
So-
I thought it was the y minus.
That's the equation. When you're looking for the
Oh,
equation.
okay, so, yeah, sorry. Let me explain this a little bit more in depth because I skipped a step. So you're right. This is y minus this y thing is equal to this slope times x minus this x coordinate. You are correct in thinking this, but we want the slope of this. We only want this value right here. While we could find the rest of these things, it's not necessary. We only need this value for the slope, which means we're really only finding y prime. So I need to find y prime by taking the derivative. And this is simple Dowder times dinner. So Dowder is what?
1 over x over 2.
1 over x over 2, exactly. And that turns in, well, before I simplify, then I do dinner
1/2.
times a half. Perfect. So now I need to simplify this. When I do 1 divided by anything, that's really the reciprocal of this. So that's equal to just x over 2 times 1/2.
I was scared I was going to do that.
Oh, what am I doing? It's the reciprocal. I didn't do the reciprocal. 2 over x times 1/2. Sorry, Sophia, what were you saying?
I was scared I was going to do that wrong, so I just plugged in 4 right away. Like,
You can't do that. You have to take the derivative and then plug in 4.
no, I took the derivative, and then I was scared I'd do the reciprocal.
Oh, yeah, perfect. That's a great method.
Yes.
And that simplifies to 1 over x, and then I need to plug in 4. That is 1 over 4. The correct answer is B. And I think Sophia's method is probably safer to do if you don't want to memorize all these rules, to just plug in right away.
Do it, guys. Do it.
All right, questions on number 5. Do you want me to do it Sophia's method, or are we good?
We're good.
We're
We're good? All right. On to the last, wait, is this the last problem?
No, we have 3 more. 2 more. 3 more.
3 more, including this one, yeah.
Kind of sounded like these ones.
All right, so y prime is greater than 0, so that's the slope. It needs to be positive. And y double prime, that's going to be the concavity. Concavity needs to be negative. So slope needs to be positive everywhere. So this one is positive, positive. That's a negative slope. This has multiple slopes. That's always a positive slope. And concavity needs to be negative everywhere. That's a positive concavity. That's a negative concavity. Good. That has both concavities. So the correct answer is B. you want me to explain that slower?
No. I just sometimes I get confused when it's like the graph of like f prime of x, and then you have to find y double prime. Like instead of going up one concavity, what would it go to again?
So if you take the derivative of concavity,
Yeah.
you go into jerk, which we don't worry about.
So it never happens.
It happens in the real world. It doesn't happen in the AP Calc test.
Okay.
Oh, because it's like triple.
We don't worry about jerks in this class.
How do you take the derivative?
Yeah. Oh yeah. What did you do?
All right, so let's move on to number 7. So we have this graph. Which of the following is an equation of the line tangent? So this is definitely where we want to do y minus the y coordinate is equal to the slope times x minus the x coordinate. All right, so what do we have here? The x coordinate is -1, and we need to find the y coordinate, so we plug that in. So I do f of -1, and I plug in. So -1 cubed is -1, so that's going to be a -4. -1 times -5 is a +5 plus 3. That's going to be 5 plus 3 is 8, minus 4 is 4. So I have a 4 for my y coordinate. And to find the slope, I need to take the derivative. So that's going to be f prime of x. I'm just going to, f prime of x. And that's going to be 12x squared minus 5. And then I need to plug in, come on, Mr. Sindel, write a little bit neater. I need to plug in -1. And -1 squared is 1 times 12 is 12 minus 5. That's going to give us 7. We need to simplify this a little bit more. So that's going to turn into y is equal to 7 times x is 7x. 7 times negatives kiss, that's going to be a +1. 7 times +1 is a 7. Then I'm going to add 4 also, so that's going to be +11. And there's our answer C.
Mr. Sindel, this problem has been on every single test.
Yeah. I love this problem.
Yeah, I think this problem
No,
is
wait,
like,
you should keep it on.
yeah, I mean, what? I don't have it memorized.
All right. Well, if you memorize it, great. That just means that you're paying attention. All right, number 8. So I need to take the integral of this thing. You'll notice that dinner is not 1, therefore we're using taxman or u substitution. Let's do taxman because that's faster. So I need my u, which is 3x plus 1. I need my taxman. I'm just going to write tax to abbreviate. That's going to equal, there is no taxman, so 1. And then I need my u prime, which is 3x. Oh, sorry, it's 3. This fraction is now 1/3. So I'm going to pay the taxman. That's going to be integral of 1/3 integral of, oh, I pulled out the 1/3, but I wrote the integral twice. That's what happened. Okay. 1/3 times 3x plus 1 to the power of 5 dx. Then I take the integral, so I have 1/3, and then this is going to be 3x plus 1 to the power of 6 divided by 6, and that's going to be 1/18. Answer is A. Everything out of 1 point. So if you scored your own test, add them up now. Score it out of 29. They should be out of 29 on the very front. And Carly, make sure that you make that change out of 29 on the very front of yours as well, please.